My name is Badi. I work at Intuitive Surgical, and we make robots. So these are not the sort of autonomous robots. These are more medical devices where there's a person operating some system. And so this is sort of showing an example of it. On the right-hand side over here are the instruments that actually go into the body cavity. This surgical team makes small incisions, and then the instruments go in. And everything you see here is set up so that the surgeon themselves could potentially be in another room doing this. The goal here is to have the best possible patient outcome with as minimally invasive procedure as possible. And the complexities come here in terms of as motivating factors for how we ended up with the stack that we're using are that need to be built to make this to work properly. There's going to be an example of the scale a bit over here, but some of the interesting things here is that these tools give you a bit more degrees of freedom than our human wrists actually have. So in this case, this is something that's a bit closer. Is this better? Better? Higher? Yeah? Maybe? Okay. So that was, I'm not sure if that helped give you a sense of what the actual thing that we tend to build is. But there's some complexities that come from this. We're a regulated entity, so the development cycle sometimes is on the order of months to years. There are, in this particular case, there are many embedded targets that need to have their software built, tested, vetted, documentation provided, software bill of materials generated, and checked out. These systems are in use for a long time, long after the bits on the internet tend to go bad. In terms of development cycle, where we use a monorepo, which on single checkout is roughly 200 gigs. There's a lot of artifacts that go into there. We use work trees. Each of those can be, like last one I had was about 30 to 40 gigabytes, just as a work tree. A lot of the different components see a lot of churn, some of them less. And there are some external things that are these giant software blobs that have to be somehow passed along through the whole system. That provides a lot of issues. We have some very specific toolchain requirements. So we're at a point where the company has been in existence for like 25 plus years now. There have been several iterations of the product, several different build systems that have been used. The latest one is a combination of using Nix and Bazel. Both of these have some very specific properties that we're interested in. Big one that Bazel has is, that I'll talk about a bit more, is granularity. But overall, we want to be able to build fast because then you can iterate fast, you can test fast, and have overall a better developer experience and ultimately a better patient outcome. So some of the things that we need are to be able to reach really deep into the dependency graph of the software that we are building and shipping. We need to be able to cache different things because the big systems, in order to go fast, everything you have to have different layers of caching. We have to be able to do this without the existence of anything on the internet. So if Google went down or GitHub or whatever, we should still be able to build our software. So this talk specifically is less about here's something that you can do right now to build, but this is more of a, let's take all these different ideas that we've seen at different talks, NixCon, and show how we're actually composing them to have a stack that uses them. And as with all software, we have it working, everything's awesome, asterisk. There are a lot of issues. So this is a quick calibration for me. Kind of like, these are the general Nix concepts that we'll have in this talk. Does anyone not know what they are? Or is it helpful if I go into these as they come up in the talk? Yes? Yes? Okay. So, why Nix and Bazel? Uh, Nix, we have Nix packages, which has a vast wealth of knowledge of how do you build pretty much anything. And if it's not in Nix packages, a lot of the core ideas of how to build something in a reproducible manner are there. You can build things with autotools. You can build things that depend on CMake. Some things are just bare shell scripts. You can build things that are just files. It doesn't necessarily have to be an actual build system. There is pretty good support for cross-compilation, which is kind of critical for what we're using. There's all this, like the last talk was about substitutors and caching, which are critical for how we're using this, though I don't really talk about it much here. Bazel has really a good cross-compilation support in different platforms. There's a good caching story. But critically for us, it has a very fine-grained build system where each of the different components are more or less content addressable. Nix has some support for that, but it's a bit more experimental and it's not quite as mature as we're looking for. So that's the ideas here is like take the best of Nix, take the best of Bazel, smash them together, and it works. So that's the sort of cake we're trying to go for. So Nix provides our interfaces with the layers of impurity. So anything that we need to pull in from the outside world, tool chains, libraries, that sort of thing, we shove them into Nix. And then Bazel has an interface onto that that allows us to build for a particular platform all the packages that it needs, and then expose them to the Bazel library or application for that particular target. So more concretely, these are the different things. So this is sort of the theme of the next bit of the talk, and I'm going to go into a bit more individually. But some audience participation. Does anyone know what this structure of thing is called? Or shout it out. A package? Recipe? Anyone else? Derivation? A function? So a lot of these are all right in a sense. We call this particular form of something, which is a function, to a derivation, a recipe. And the reason we call that is because that has been a good a notion for us to explain to our users who are developers at the company who don't really want to know, care, or should care about Nix, what it is that's going on here, and allows them to think about how we're composing the different layers together. So what's happening here is that this is a function that takes something called a standard env that produces a derivation. Its name is pname. So we're passing in the parameters to the make derivation function, like parameter of the name. The pname is hello, version, etc. We have some string interpolation where this hello.c is a path in the repository who then gets interpolated at sort of this build time to its location in the Nix store, and it builds this hello application, and then, excuse me, there's an install phase that then takes the output and shoves it into the target output. So, yeah, that's what we call recipe. This is something slightly different. What's going on here? Any ideas? Okay, I heard overlay. I heard overlay. I heard overlays, yeah. So yes, this is implemented as an overlay, but what we're trying to capture here is more or less a database of packages that are available to our systems that will later be used in different overlays. So in this particular case, we may have different versions of some library or application. OpenSSL, just to pick on that, is like you have multiple different versions of OpenSSL. You may want to experiment with a different version at a particular point in time for a particular version of your hardware that you're experimenting with. Say you want to go to market with one thing, but you don't know if this thing actually works, but you don't want to negatively affect everything else that you're building that's in sort of production. And so this gives you a way of exposing different things, but these are lazy. So this is not actually the overlay for, say, AR64 Linux or x86 or whatnot. So the way we're thinking about this particular component is a package database. And now, I heard overlay for this sort of thing, yes. This is what we're explicitly calling an overlay or a package set. Because for a given platform, and this could be bare metal, this could be embedded Linux, this could be x86, it could be a Ming W-based toolchain. You want to have a set of packages that are accessible for that. Overlays are a way of doing dependency injection into the set of packages that you have. And so this when you build the target binary, will inject those with the different dependencies. So in particular, in this case, we have some recipe for something that has different dependencies, systemd, for example. Some targets do not support systemd. Some targets do. Some things, like, I don't know why you'd want to turn off OpenSSL, but sure, this gives you the chance. And then the overlay is where you can compose these for that specific configuration. And this is how that comes in. So when you import Nix packages, there is a parameter to that import that you specify that overlay. And you can have multiple layers of these overlays that then get sequentially evaluated. And then in our case, we have cross-compilation support. So target A, target B, or whatever, gives us the ability to specify what we're building for. We are additionally using overlays as an allow list. One of the issues that you come across with the mingling of Bazel and Nix is, at least with overlays, you expose your set of attributes in that overlay, but they're mixed in with everything else. And so when you're trying to build a particular version of, say, OpenSSL, you want the build to fail if you haven't exposed the right one, or if it's not explicitly set in the overlay. So we do some cursed things, as someone was talking about yesterday, to make that work. So at this point, this is our stack. At the bottom, we have these recipes. Then we have a package database that then exposes all the different versions of a particular package. And then we have a particular overlay for the different targets that we're interested in. And now we need to expose them to Bazel. So this is where one of the, so when we expose something to Bazel, we need to tell Bazel, in this output, these are the different files that are accessible. Nix has a great feature of splitting the outputs into different locations, so into different paths. And so when you build a derivation, you build essentially the first one in your outputs list. But we often actually want the library files, or potentially documentation, that are not packaged in the default output. So we need to essentially symlink join them, so that this takes all of the outputs, generates a new derivation, a new package that exposes them. And at this point, we are able to operate entirely in Bazel. There are some steps here that I'm not actually really going to cover. On the left, there's this register toolchains and toolchains.nix. That's where we tell Bazel that for a particular overlay for a target, this is how you actually invoke it, and how to expose those toolchains to Bazel. But there's some work there. The infrastructure that's driving some of this is a lot of the work done by Twig, where you can expose Nix packages attributes to Bazel using the Nix packages, the rules Nix packages libraries. And at the very top, you have now your nice, beautiful Bazel library that depends on something in Nix, and it just works, quote unquote. So this is the type of commands that are like I ran yesterday, more or less. You have some package, you do a Bazel build, you specify the platform, and under the hood that essentially calls down to Nix to build something like that generates the output paths. It then goes through the overlay to wrap those in the form for Bazel, and then Bazel has access to the files there that are then linked into this package that we're saying. And by changing the platform, we can potentially change the versions and so forth. So this is kind of a convoluted, complicated stack. You might ask how we ended up here, and we didn't start with this. We had a lot of the layers between Nix and Bazel where we just had the recipe, and then Bazel interacting directly with those. And that worked for a while, until we wanted to have a nicer interface that developers could have with the systems. Say this, without this, the overlay, you would have to specify for a particular library in Bazel the version of the library that you're looking for. And that doesn't scale for the host of different targets that we're trying to build for. So yeah, it's nice and beautiful. Not really. So some things worked really well. If you've never used breakpoint hook in your Nix derivations for debugging, heartily recommend it. It's changed my life. What this allows you to do is you add a breakpoint hook into your native build dependencies or your build dependencies, and as the build's progressing, if it fails, it will pause, and you can directly enter the environment of the build and tinker around in a very mutable, impure way. Having the different access to the different layers, both for Nix and for Bazel, has made debugging much simpler. One of the issues that we have is many developers. We have a binary cache that we push all our CI artifacts to. So everything runs on a Nix build, pushes to cache. That's not public. So instead of having developers install directly from Nix, we wrap that up with a like Debian or RPM or whatever package. And that sets up all the configurations. They just install that. We've been as we go through onboarding and talking to developers about helping them do the development that they need to do. Sometimes there's a need to add a third-party package or something, and they're not versed in Nix. And our job there is to make it easier for them to both think about what they're trying to do and how to do it. And so some of the terminology that we've been coming up with, like we found that when we talked about recipes, instead of derivations, things started to click for them very much faster. Let's see, yeah, caching is great. We recently had a issue where things were working previously without Bazel Nix by luck, essentially due to the impurity on the systems that people were developing on, and things started failing when in the Bazel and Nix world, essentially because we were catching a latent issue that no one had found yet. So all the rest is met with love. Let's put it that way. We talked about the multiple outputs. This was a problem until we until we were able to wrap this up. So fundamentally, wrap for Bazel is a sibling join. There's a lot of cross-compilation here. We inject custom tool chains into the overlays. Sometimes we want to have a different tool chain build the entire set of packages, rebuilding the world. It's for people who are not very tuned into how Nix packages work or very familiar with the ecosystem, that can be a hard thing to wrap your head around. Talking to users about what does this mean, or why are we doing it this way? Having better ontology to describe the different roles for things and the different patterns that things fit into, and how they compose to provide the build that they're trying to ultimately do. I'm going to skip this one. We have an interesting situation where the target outputs are actually not running on a system that have access to /Nix. And we can't really copy the entire closure over. So we need to do some interesting things to make it work. So conceptually, Nix requires the interpreter to be present in the Nix store during the builds. But we can't actually point to the, but then that infects it. And so when you copy this over to the target, it can't be run. And so there needs to be some phases that split that out or change what that interpreter is, modifications to patch ELF, that sort of thing. There's some, say one in particular, is 20 gigabytes of something. That depends on a lot of other things, but it's depends in such a way that any modifications to what it depends on changes this blob. And so every time that changes, new 20 gigabytes, new 20 gigabytes. It's easy to burn through terabytes in a development cycle. We don't have a solution for this yet. Yeah, if you know, you know. Yeah, let's see, how do I say this? Python is great. I heartily recommend Poetry to Nix for what we've experimented with. There are a lot of different options. Poetry to Nix has been one that has gotten a lot of things right, as far as I can tell. And I think, actually, yeah. Overlays and infinite recursion go hand in hand. So yeah, I'm actually just going to jump to the end. I want to leave room for questions. We're also hiring if you love Nix or reproducible builds. Talk to me, talk to my boss, emails. I'll be around here. Please talk to me. Questions? Yep. Yep. We take a look at the attributes that are in the overlay specifically and remove everything else. Everything that's not. And then, yeah, there's another layer that inspects it and does that. Oh, sorry. Yeah, the question was mentioned about how to use overlays as an allow list of the packages. And yeah, so I think I saw in the back. Yeah. So looking at the question, what are the expectations on your developers for reading and writing Nix files and reading and writing Bazel files? Most of them only. Oh, sorry. What are the expectations for our developers between reading Nix files or having to deal with Bazel? Most of them just deal with Bazel. There are a subset, maybe 25%-ish, that do enter the Nix world. So I think they're in the orange sweater, yes? So question was, what does the CI environment look like? Patches to Bazel. So we try and push things to the cache as possible. There's a lot of remote caching, local caching, and disk cleanup on the fly, if that helps. I saw a question here. Yes. So Correct, yeah. The question, so does Bazel call into Nix or Nix call into Bazel? It's Bazel calls Nix. Why we did that is this started out because we wanted the fine-grained builds that Bazel provides. Yeah, so like at like a few lines of code is more content just. Yeah, over there. With Nix. So everything is intended to be indexed by the repository. So you should be able to check out the repository and enter the environment, essentially a shell.nix. And that gives you everything. So you can upgrade Bazel, you can revert Bazel. The developers only need to run our installer for Nix itself, and it works. Yep. So, so the question is, how do we integrate with these blobs on the Bazel side? Is that- so because we want to be able to essentially check out the version of that binary by checking out a specific version of our code base, we have to provide it by Nix. And that's where the friction comes from, is really that iteration on the Nix side for people in unrelated teams can impact this because of just how it depends on, say, Python. And if you change something that Python depends on, which is a lot, or even one of the Python libraries, the way it's structured is that kind of blows up. But for how Bazel calls that, it's some targets or rules that specifically say run the binary that this blob provides. It's less of an issue on the Bazel side here. But the challenge is that it needs to be provided the way we've structured things with Nix.
All righty. Let's wrap things up there. If you have more questions, meet the speaker outside or at lunch or wherever you feel like. But